All right, we all good? We all dealing with a cleared calculator at this point?
Yes, ma'am.
All right. Okay, so people have felt really good about today. Like if you kind of felt like you were on the struggle bus the last couple days, like today the level of complexity would be a lot better. Okay? Thanks. All right. Does this look familiar to you if I show you some scatter plots and I ask you what type of correlation exists? Would you know what we're asking for there? Yeah, like what type of correlation? Like so for this one, do you know what kind of correlation? So like relationship between x and y that exists there? From Algebra 1, right? What would you say? Anybody?
Negative.
Negative. Yes, thank you. Yeah, this is a negative correlation. And we know that because it kind of looks like the points are going down. So this means as x is increasing to the right, y is decreasing. Okay? All right, the second one, when our points are kind of all scattered all over the place. What's that one? No correlation, and I'm just going to write none here. Okay? And here, this one would be positive. Because as x increases and goes to the right, y increases. Right? Okay, great. If you have a test question on that, we all get that one right? Yeah. All right, great. So this next question is asking us about names of lines, and we'll talk about that in a second, so I'm not really going to answer this question down here. I want to take this space to remind us about something called the correlation coefficient. And if you don't remember what that was, at least is that term familiar to you? Okay. The correlation coefficient is something that the calculator can tell us, and it measures the strength of the correlation. Okay? So like, I could have a lot of different looking scatter plots that are negatively correlated, right? I could have those points kind of scattered but still looking negative, and I could have those points really tight together and still be negative. So this is a value that measures the strength of that correlation. And that number is between -1, so I'm just kind of drawing a little number line here. It's between -1 and +1, with obviously 0 in the middle. And the stronger you get to either one, the stronger correlation you have. So as I move to the right, I have a stronger positive correlation. And as I move closer to -1, I have a stronger negative correlation. So that just means how tight your points are, right? And 1 and -1 means an exact line. So all the lines we've been graphing have had a correlation coefficient of 1 if it's a positive slope, or a -1 if it's a negative slope. And anywhere in closer to 0 would be considered weak. Okay? So we can kind of measure that way. Okay. So down here, it says that we can draw lines on our scatter plot to help us predict what will happen outside of the data that we are given. Draw a prediction line on the graph. Whenever you see the word prediction line, that is something that you yourself are physically drawing. So you draw a prediction line, or sometimes it's called a trend line. Okay? And when you do that, you're basically going to line up your ruler as best you can. You're going to want to make sure you hit 2 points that you just think best represents the data. But there's one thing you have to think about before you do that. You have to ask yourself, should I include the origin? Should I include 0, 0 in my trend line? And that really is just going to depend on what the situation is. And it looks like we're looking at number of pages that we read versus the time it takes to read that. So if we read 0 pages, would we be reading for 0 minutes? Don't overthink it. If you don't read, how long do you read for? No time, right? So would we draw a line through 0, 0? Yeah. 0, 0 is a valid point here. It's not a collected data point, because why would they ask somebody who doesn't read this question, right? They're not going to do that. But we want to make sure when we draw our line, it's going to go through that point. So take your ruler, and you yourself draw what you think is the best trend line that goes through, that will show what those points are doing. And then after you draw your line, answer that multiple choice question for yourself. Predict the time that it would take to read 50 pages. So based off the line you drew, select your answer choice and just circle it, and we'll see collectively what we all picked as our answer choice. Okay, can we vote? Raise your hand if you picked over 40 minutes, A. Okay? Are you kind of looking, because that's clearly what mine says? Okay, well, mine does say that, so I'm in the A club. B, between 35 and 40. Anybody pick that one? Okay. C, between 30 and 35. D, between 25 and 30. Okay. Well, the actual right answer is A, over 40 minutes, but some of us got B. And why do you think we could have gotten different answers? Did we all draw the same line? No, that would be weird if we did, right? How would we all sync and draw our line the same? Okay? That's because there's a little bit of error when we do this, because we're humans. We're just drawing the line we think looks good. Okay? But there are people who have jobs based on taking data and making predictions for the future. There are so many jobs that would involve, right? So there has to be a better way than just what I think, right? Okay, and that comes when we're drawing something called an exact line of best fit. When you see this phrase, line of best fit, that needs to clue into you that you are not drawing that. That is something the calculator is going to figure out for you. So when you see line of best fit, you need to think, I need the calculator, because I am not capable of drawing the absolute perfect best line for that. Okay? And I'm going to run through with you how you do that in the calculator. I'm going to write out all the steps first, so if you would just copy those down, because you're going to want those later, okay? And then we'll do it together. So first we're going to write the step. The first thing we want to do before we even begin the process is to turn on stat diagnostics. And again, I will show you how to do that after we write this down. So turn on stat diagnostics. And then step 1 to finding the line of best fit is we are going to hit stat edit. Step 2, we're going to enter our data in L1 and L2. Step 3, we're going to go to stat calc. Step 4, we're going to choose linreg. Step 5, calculate and write equation. Okay. All right, we all good? Okay, let's make sure our phones are put away because they're not supposed to be out right now, right? Okay, let's do that. Now that we have it written down, let's do that together. So we have our cleared calculator, right? All right. First, we want to make sure our stat diagnostics are turned on. Every time you clear your calculator, this setting turns off for some reason. Okay? And to turn it on, we go to mode. So hit the mode key. Mode is right next to second, by the way. And we want to go down to stat diagnostics, which is in the next screen. So you're going to go down. Okay? We're going to turn stat diagnostics on. So just highlight it and turn it on, okay? Everyone good there? That's a necessary step that you'll just have to do if your calculator's been cleared. Okay. From here, now we're going to follow these steps. So hit stat. Stat is the second button from the top on the right. Okay? And you want edit. So hit number 1 for edit. And you should be looking at this. We all should be looking at the same screen because we all have cleared our calculators. Okay? All right. From here, you're going to enter your data. And our data has been given to us in this table right here. So X's appear in L1, Y's appear in L2. So we're just going to type in these numbers followed by enter. So. Okay, we all good? All right, so I'm going to take a side step before we go to the next step. Let's look at what this actually looks like as a scatter plot. Okay, to do that, we want to turn our stat plots on. So everybody see stat plot in blue above the y equals key? You see that? To get there, let's hit second y equals. And you see all your plots are off, which means it won't graph you a scatter plot. Take plot 1, so hit enter and turn that on. And to turn it on, you hit enter. And then just hit the graph key. Hit graph. And then you actually see those points. Okay? So what kind of correlation does that look like it has? Yeah, positive. What do you think, strong or weak? So are those points pretty tightly in a line almost? Yeah. I would say that's pretty strong because that's almost a line, right? Okay, so its R value would be probably pretty close to a positive 1. Okay, now we're going to calculate the line of best fit. So we're going to pick back up in our steps. So we want to go to Stat, Calc. So hit the Stat key again, which is right here. Stat. This time we're going to go over to Calc. And we want to choose number 4, LinReg. Okay? And then you're going to go all the way down to calculate and hit enter. And it gives you a whole lot of information. Okay? Okay, so the calculator tried really hard to get the best possible slope and the best possible y-intercept for the best possible line to go through those points. So we have to write the equation now. And we're going to have to round, right? Because we're not going to write all those. Yes? I turned the stat diagnostics on. That was that first step we did. Mode, and then turn stat diagnostics on. Okay, if the problem does not tell you how to round, and it doesn't say round to the nearest hundredth or whatever, the default that we're going to use is round to 3 decimal places. Okay, so if it doesn't tell us, that's how we're going to round. So our equation, so we're going to now write our equation. And they're giving it to us in slope-intercept form. They just use an A instead of an M. Okay? But our equation is y equals A, which is 2.380x plus B, right? And our b is negative, so instead of writing plus, I'm going to write minus. So minus our b, which is 4.866. And do we all know how to round? Right? We're there that day in elementary school when they taught us how to round. If I tell you to go to 3 decimal places, you look one further, and if that's less than 5, you keep it the same. If it's 5 or more, you bump it up. Okay? All right, and what's our correlation coefficient? Point what? 9.7, well, technically 971. It's not r squared, it's r. We want the r, not the r squared. Okay? So that just means, hey, this is pretty strong positive, right? They didn't ask us for this information, I'm just giving it. Okay? Okay. We're going to get a chance to practice those calculator steps if you got a little off on them in just a second. All right? All right, ready to move on? We good? Okay. Number 4, find the line of best fit for the data shown in the graph. All right, are we drawing that or is the calculator doing that? Calculator, line of best fit is calculator, okay? So we can't just put a scatter plot on the calculator. The calculator needs numbers. So we have to take those points and we have to put them in a table so we can then type them in, okay? And we don't have to worry about going in any specific order. As long as we just put in these points, we're good. So let's do that together because some of these are a little weird. So it looks like this point right here appears to be 1, 5, right? The x is 1, the y is 5. This point looks to be 2, and what do we want to say that y value is? 4.5, that works for me. And then our next one is 3. And we have 4, a little more than 2. So 4, what do you want to say? That's 2.1. I can go with 2.1. And 5, 2. And 5, 1. And 6, I guess 0.5. And there's one more. Do you see that last one? It's kind of hard to see. It's right here. 8, 0. It's an x-intercept, right? Okay, so you try this now. So you're going to plug in the data, give me the equation, and also give me the r. Okay. When you go to type this in, and you go to Stat Edit, and there's already stuff here, do you know how to clear the list? Yeah, you just go up, so you're highlighting L1, and you hit the clear button, and then enter, and it clears it out. Go over, highlight L2, hit the clear button, hit enter, and then you're good as gold. Okay? So you try that. Let me know if you are having troubles, if you can't figure something out on the calculator, and I can help you with that. Yeah, this one also doesn't say how to round, right? So round to 3 decimal places, just like we did in the last problem. Anything else? setting it up for you. That's slope intercept one, right? Just instead of an M, that's an A. So you're just going to use this number for your slope, this number for your y-intercept. But you're going to keep all the digits. If it doesn't tell you how to round, then you round up the decimal places. And then just at the bottom, just give you the R, just to you know about it. It doesn't actually tell you to give it in the problem. Yep, because you have a negative slope and then it's pretty, yeah. That's right. See if you can answer the multiple choice question. Okay, great. Okay. All right, if we have this, we are correct. Y equals negative 0.775x plus 5.558. That's our equation. Okay. This number right here, round it up. Okay, so if you didn't get this number, it's because we didn't round correctly. Got to know how to round. Okay? And then the R is negative 0.964. So what kind of correlation is that telling us? Strong negative, right? Which is, I mean, yeah, that makes sense. Those are pretty tightly in a line, almost. Okay. All right, test question. And I say test question because there is a question that will be on your test in a couple weeks that is almost this exact question, just different circumstance, okay? The function y equals 8 minus 1.5x was drawn. This is not a question, should not be a question mark. Which of the following would create a better trend line? So obviously, this trend line doesn't even hit any of it, right? And trend line means somebody drew that. So somebody thought that was good. Okay. So basically, what could you do? Well, which one of these answer choices could you apply to this line to make it a better fit? So read those, make your choice. Don't be afraid to be wrong. Make a choice on the paper what you think, and we'll talk about what the right answer was. Okay. We all make a selection? Have we made a choice? Bless you. Okay. Andre, what did you pick? A, B, C, or D?
I didn't really pick one.
I will give you a hint. The right answer is A, B, C, or D.
Okay. That's not close. So,
Okay, let's look at that. Obviously, this is a bad line, right? It doesn't hit any of the points.
mhm.
So, without looking at these, what could you like physically do to that line to make it better? Like, what would you do?
Shift it over.
Shift it over? Okay, how over? Like, what direction over?
All right.
You'd move it to your right?
Wood.
Oh, okay. I see what you're saying. All right. I get that. I get what you're saying there. Do any of those answer choices mean shift to the right?
No.
Okay, is there another shift that you could do to that?
Shift it up.
Shift it up? Do any one of those answer choices mean shift it up?
Yeah.
Yeah. Which one? B. B is the right answer. You want to increase the y-intercept by 10. You're just basically moving it up. If you change the y-intercept, you'll move it up. If we wanted to swing the line around, that would be a slope change, but that's not what we want to do. Okay, last question. All right, I'm not going to read you this little paragraph here, but basically, when we interpolate, we are taking a set. We're trying to make a prediction based off of information that we have, and we're making a prediction about something within the data. So like if I have this set of data and I'm trying to make a prediction about something that's inside of it somewhere. If I want to make a prediction about something outside the data, like future prediction, that's extrapolation. Okay? All right, so we're going to do that same thing. We're going to try to create an equation to fit the relationship between the population of a state and the number of people who have a driver's license in that state. Okay? All right, does this problem tell us how to round? Look at it carefully. Are there rounding instructions here? Yes, so we want to follow those, because if this were a test or a quiz and we didn't follow the rounding instructions, we would get dinged on that. Okay? Hundredths, okay? Third grade review. How many decimal places is the hundredths place? The second. Thank you. Yes, so 2 decimal places. Okay? We're going to use population as L1 and licensed drivers as L2. Go ahead and put this in your calculator and write your equation. Okay? You don't need to give me the correlation coefficient, the R. You don't need to give me that. Just get an equation. And remember, you can clear your lists out quite easily. If you don't know how to do that, let me know. Okay, we have an answer from, let's see. Cameron, you got it for us? What step in the process are we on? Have you put it in the calculator? You put the data in the calculator? Okay. Did you hit stat calc? That's what you're on? Okay, go down to LinReg number 4. Did you do that? Okay, go down to LinReg. Okay, go down to calculate. And a whole bunch of stuff pops up on your screen, right? All right, so what does that say? Y equals, what's our A value? 0.59, yep, this is 0.59x, right? And then what? Yep, plus 0.57. All right, if we have that, we are correct. Do we all have that? Okay, if you did not get these numbers at all, that means you did not plug in the numbers in your table correctly. Okay? If you got almost these numbers but the rounding's different, that just means we didn't round correctly. Okay? If you're having trouble rounding, see me, go to a YouTube video, how to round, whatever. Okay? But I'm not going to spend our time on rounding. Okay. So now I want to show you some calculator tricks to what you can do with this to answer questions. Okay? So if the population of West Virginia is about 1.8 million, how many licensed drivers would you expect them to have? So it's basically saying, what if we had West Virginia here, right, that has a population of 1.8 million people, what would be the number that you would expect to be there? And there's a couple ways you can figure that out. You can take 1.8, and that's in your X column, right? So you could plug that in here, and you could get an answer. Or, my favorite way, put this in the y equals of your calculator. Okay? So go to the y equals of your calculator. If there's something there, clear it out. And type this in. 0.59x plus 0.57. And then from here, let's go to our table. Everyone know how to get to the table? You go second graph to get there. Second graph. We all there? Okay. So I want to make this clear. You are not looking at the table we typed in. That's not what we're looking at right now. We are looking at a table of x's and y's for this equation. So if I want to look up 1.8, I don't have 1.8 because my x's are going by 1. Does anyone know how you can change that? Yes, ma'am.
Do you press like second and then table set or no?
That's exactly what you do. Yeah. We would go into the table set. So you go second window will get you to the table set. And here you can change all kinds of things about your table. You can change where it starts. You can change the increments. So right now it's set to go by 0.1. You could have it go by, or I'm sorry, it's set to go by ones. You could have it go by 0.1s if you want to get to 0.8. But my favorite one is to change independent off of auto and put it on ask. Has anyone ever done that before? Okay, I'm teaching you something new today. Great. So go down, take independent off of auto and put it on ask. Okay? And don't worry, you can put it back when we're done and it will be normal, okay? Go back to the table. So go second graph to go back to the table. And it looks like you have no table anymore. But this is what it's doing. It's waiting for you to tell it an X, and it will spit out the answer for the Y. So all you do is type in 1.8, hit enter, and it gives you the answer. 1.632. So you could do that for any x that you want to find, okay? But we're not going to write down 1.632 because there were some rounding directions there, right? To the tenths. Okay, second grade review. How many decimal places are the tenths? 1 decimal place. Okay, so we're just going to write 1.6, but remember these are in millions, so I'll write 1.6 million. Okay? Okay. Now, since you probably don't have one of these calculators at home, maybe you do, maybe you don't, after you glue these notes in your notebook, so I'm going to fold it in half, put some glue on the back, put it in the notebook, I want you to try the odds on this sheet that you were just given. So glue in your notes, try the odds, and why do you think I'm telling you to try the odds? What are you supplied with? Answers. So you can check to see if you know what you're doing, okay? Do that right now in class because you can't take these things with you when you leave, okay? The calculator. You can take your stuff with you. You can't take the calculator with you when you leave.